The search function in EIM for groundwater can be conducted in one of two ways, or a combination of the two search methods that we're going to discuss. So the first search I'm going to show you is just a basic tabular search. So this is the tabular search interface for EIM. You'll notice it's just a series of fields. These are some of the metadata fields that Chris talked about earlier. And they're broken down into essentially the location study result data model. So the well tab here represents the well information that you might potentially want to search by. We have locational information. If you want to do a geographic search, we date range options. You can search by parameters. So for water levels, for example, you could select a water level type and do a search. Or you could search by study. If you have a specific study that you're interested in, you could search just for that study information. So I want to show you a few filter functions that have been built into EIM before we actually do the search. So if you're interested in wells, for example, that where Aquifer tests have been conducted, we could hit this little tab here and do search. That'll return a list of all the wells where formal Aquifer tests have been conducted and documented within EIM. So that's a very powerful, quick access to information if you want to look at wells where a well log has been connected to the system. Very quick. So you can use these filters in conjunction with the other search features in EIM to really get some powerful downloads of information. So in this case, let's just do a search for a well. I'm going to limit my search to wells between 10 and 50 feet deep. This will just give you an idea of the sorts of things that you can do. We're interested in wells in Pierce County. And let's say we want to look at arsenic data as our parameter. And there are many options for arsenic. I'm just going to pick the first one. And let's say we want to limit our results just to groundwater. We're not interested in soils or sediment data at this point. So you can see it's just a very quick pick list sort of search option. And in this case, we got 73 results returned. So that means there's 73 locations that met our search criteria. Now, EIM has a feature that allows you to look at what your criteria were for your search. And perhaps you might want to modify those. You know, there's a way to do that by it hitting the edit search function. But in this case, we have wells in Pierce County between 10 and 50 feet deep where groundwater was sampled for arsenic. So those are our search criteria. Now, you'll notice that the results are returned in a series of tabs. So the location result study concept is retained throughout the system. So in the case of wells, you notice that there's a little drop-down dialog box here beside each well. That opens up a number of options for users, not the least of which is the ability to look at the well details. So this is how you get at the metadata for a specific well. So in this case, we can see a pop-up map of the well here, information about the well itself, its construction details. Chris mentioned that you can link wells to other databases. So in this case, somebody has linked this well to facility site. You can see that here. So if you want to know what the facility information is for this particular site, it's as quick as that. You just click the link, and there's the information. You can get some basic data about that particular facility. Chris also mentioned this concept of alias. This is where we can add information. For example, if this well had been tracked in the USGS NWIS system, we could input the NWIS ID in the alias field, which would then provide a way for users to link this particular well to data that might also be contained in the NWIS system. We're just sort of showing you the basics. Now, if you wonder what for example, the completion interval might be, all of these fields have a little pop-up dialog help. And this is true throughout the system. If there's a field that has highlighting or some sort, know that beneath that lies information that can potentially help you understand what you might be looking at. We have information about the measuring point. This all ties into that metadata about the water levels that Chris was talking about. You also have a summary of the information that's been collected for this well. You can view the data at this point, which I'm not going to do just to speed the process up here. Also coordinate information. So this is all available via the basic well details. You'll also notice that we have the ability to chart the data within EIM. This is something that's specific to groundwater. Other aspects of EIM don't have this particular feature, although I believe that is...
It's coming.
It's coming. Yeah, so you'll notice that we did our query initially for arsenic, but we have results beyond arsenic. And basically the charting function at this point provides access to all the information that might have been collected for that well. So that you can see that this well has a whole variety of contaminants other than just arsenic that you might be interested in graphing. Let's just grab one and see what pops up. So we have a single data point for this particular parameter. You can do one or many with the control shift keys, so it behaves very much like it would any other Windows product. You can see multiple graphs beneath here. So this is really powerful if you have water level histories with pumping information, with temperature data, etc. Now in this case, we don't have any water levels assigned to these wells, but we do have water quality. And here we have the results restricted just to the arsenic values that we searched for. I want to show you the Studies tab. And this is part of the power that Chris was mentioning earlier. This single query returned the results from 14 different studies within Pierce County. So historically, we would not have had the ability to sort of look geographically at data in the way that we can now. And if you want, you can actually get the information related to each of these studies. You can get to the details of a particular study. So this tells you something about the study, what facilities it might be connected to, and it gives you a broader distribution of all the wells that were studied during that particular study, as well as a summary of the data. So at this point, you could completely change tack and say, this is the area that I'm interested in, and you could actually download or view the data for this particular study in and of itself. So let's do one more thing. Let's go in and run an advanced search, and this is a nice feature in EIM for those parameters that have a cleanup level. So we might want to, in this case, restrict our results to values that exceeded the cleanup criteria. Oops. And I don't want any results that were non-detect, so I'm going to exclude the U qualifiers. So basically, this is running a search against the search that we previously ran and restricting results to that greater than 50 value. So at this point, let's go and view the results on the map and see where all these sites lie. So you'll notice the blue squares represent the sites that met our search criteria. All of the other brown dots are other wells in Pierce County that didn't meet our search criteria. Now, in the map feature, we have a number of background layers that we can turn off and on. I'm going to turn off all of the non-selected wells at this point. And I'm happy with that search result. So at this point, I want to show you a few more things, and then we'll actually go look at the data. So at this point, we could actually look at the location details again. Now, this is going to look familiar because this is what you were just seeing previously. So there are many different ways to get to the same point within the system. So once you sort of drive it for a while on your own, you'll become comfortable. You can also link to the actual charts for these wells from the map. We can do downloads, we can look at the facilities, etc. So essentially what you saw in tabular search is repeated in the map-based search. So let's imagine that we actually went and downloaded this and then opened the file. So what happens when you do a download is EIM will send you an email and say that your search has been processed. And then at a later point, it will send you an email saying your search results can be downloaded from an FTP site. Now, those, if it's a small search like this, it's usually pretty quick. If it's a large search greater than 500,000 results, it usually processes in about 2 hours. So just keep that in mind. If you have a great big search, don't expect the results right away. But this is an example of that search and the export results for the location file. So you'll notice that Chris talked about the normalization of datums. These are the values she was talking about. So EIM takes whatever the input coordinates were in an XY sense, be it a state plane coordinate, relative to NAD 80, NAD 29, et cetera. So there are a number of different horizontal coordinates that are automatically converted to NAD 83 harm and then reprojected. So later we're going to show you how you can take these coordinates and move some of this information into ArcView and use this data outside of EIM. And these are the coordinates that you would use to do that, is the normalized coordinates.
We do retain the original coordinates in the system, so that information is always stored.
And you can just see the basic information about the well, the completion depth, all of that metadata that we saw from within EIM is retained in the export file on export. Now, you'll notice that very few of these wells happen to have a well log link, but if there is a link to the well log for a particular well, that link is also exported and available to users outside of EIM. So, for example, if we click the particular link here, outside of EIM, we can then view that well log. So if you're developing cross-sections, for example, in an area, you can use this feature, if it will pop up. Here it is. So here's the well log for that particular well. So we've tried, as we've developed this system, to retain as much of the functionality that was built into the system on export so that it becomes a more powerful, useful tool for folks. And if you encounter problems, since we're here, I want to show you this bugs and suggestions tool. If you're using the system and it crashes or it doesn't behave the way you think it should, please provide user feedback to Russell or whoever happens to be manning the ship at that point. And it's as simple as pushing the report bugs and suggestions box. Tell us what the problem is, attach a screenshot if need be, and then hit the submit. And that will send an email to Russell and log this information into their PERS bugs reporting system, and they can get it fixed. And they're really quick at getting those bugs fixed these days, which is great. So in this case, let's go do a map search. And we'll just start with the map. Whoops. So let's imagine that you want to look at water levels in the Walla Walla area. The easiest way to do that is to zoom to the area that you're interested in. And EIM offers a number of nifty sort of select tools in the map view. Before we actually do the search, I want to show you, it also has a help feature. And the tools drop down on the help will tell you what all the tools on the toolbar do. So if you're wondering what the various things do and how they work, this is the way to figure that out. There's also a guide that shows you the map layer feature. So this is, we saw this earlier where you can turn layers off and on. The legend, so if you're wondering what's active, what's not, you can turn the legend on and see that. But in this case, let's just go do a search in Walla Walla, and I'm going to use the buffer feature tool, which is kind of a neat feature. It allows you to do a buffer around one of several predefined layers. In this case, I'm going to use the county layer, and I'm going to use no buffer because I only want the features that fall within the county. So I'll just click on Walla Walla County. Okay, that's what we wanted. So we now have essentially all of the wells within Walla Walla County have been selected for us. And now, in order to refine our search to just a single parameter, we have to use the search function here. This should look very familiar. This is essentially the same search we were looking at in the tabular view, but it's just within the map interface. So at this point, we can say we're interested in water levels. And another feature that I would like to point out is that, we have many, many water level parameters. I could use the Control-Shift keys and click until I had them all selected, or I could use this group function to select parameters. This is a series of pre-built tabulations, if you will, of various parameters. So, for example, we could select, I'm going to cursor down and grab water level. So this is essentially a pre-built query of all of the water level parameters. We have them for nutrients, PBEs, PBDEs, whatever the parameter might happen to be. And then I'm interested only in groundwater again. You can see that a number of wells fell off. We have a bunch of brown dots that weren't there before. So we've restricted our search now only to wells that have water levels. And we can verify that by looking at the download. So these graphs will be a bit more exciting, hopefully, than the previous ones. They actually have some data. So this is an example of some transducer data that was collected in our Eastern office. And you'll notice that there's also a temperature parameter associated with this well, in addition to the water levels. Water levels will always plot if they happen to be there. If a well has water levels, that's the first graph. It's automatically populated. If you want to look at other graphs, you have to select them. So here's the corresponding water levels and temperatures for this particular well. You can see pretty good correspondence. Now, you might want to know where these wells are on the map. You can use some tools that are built into the system. So this particular well happens to be over here, right next to that well. There's another well here. So this is an in-stream piezometer. That's a slightly different animal. So let's say I don't want in-stream piezometers. I only want to look at monitoring wells. So we can go back and modify our search a little bit. Our list just got a little smaller. So you can see you can do a very iterative back and forth search function. And now maybe I don't want the wells way over here in Burbank or way up here. Maybe I only want to select wells right around Walla Walla. I can use another tool and refine my search even further. So back and forth iterative, is a very, very useful feature. So now let's imagine that we actually went and downloaded the data. So let's see, I'm going to show you the water levels, the discrete water levels. and the continuous water levels for these wells. Now, Chris talked again about metadata. This is all about getting things normalized so that we can use some common tool sets. So in this case, the water levels were input as depth below measuring point using the top of casing, the first measuring point at the top of the casing. These are the actual water level values input by the user. The EIM takes that information and does these calculated. So if you see a field that says calculated, that's something that's being done automatically by EIM using the input metadata for the well. So we have a calculated water level elevation. So these are those normalized elevations to the NAV 88. We also have the normalized depths below land surface. So you can see this first well is missing that land surface calculated value. That's because it doesn't have the metadata that the system needs to normalize water levels as depths below land surface.
In this case, it would be the stick up on the casing missing.
Other wells do. So you'll see this mix and match of complete metadata and incomplete metadata, but where the metadata exists, you should get those normalized values, and that's our goal. You'll also notice that the system tells you something about the accuracy of the elevation for that water level. The elevation is the sum of the least accurate elevation or least accurate variables that went into the calculation. So, for example, you could have a really highly accurate physical measurement to say a tenth or a hundredth of a foot, but if the land surface elevation is only accurate to plus or minus 10 feet, that's the value you will see reported for the elevation. So it gives you a sense of how far you can push the data in subsequent analysis. Now there's a corresponding file that gets generated for the continuous data. They're not exported together. You can merge them outside of EIM if you like. They also have, similar metadata, the actual value, and then the normalized values for elevation and depth below land surface. It's important to point out here that all of these fields work when there's data, right? For the legacy data that was moved into EIM, in many cases, connections to well logs weren't made, connections to facility site weren't made, well depths weren't input. So when you do a query and you say you want something between 10 and 50 feet deep, if those fields are blank, they're going to be excluded from your result. It's as if they weren't there. Excuse me. And that's true for any of these fields. So it's just important, if you want to make sure that you get all the data, it's better to use fewer search criteria than more, because these are essentially ands. You want this and this and this.
The question was on what kind of base map can you search? Now Kirk is showing those.
These are the layers that are currently available in EIM. They can be added to. This is some of there's a piece of paper on the back asking you for enhancements or additional features that you might like to see in the system. That's a great place to add that. We would like to see the state hydrogeology layer, as an example. Are there other layers you would like to see as a background to a map that aren't here? Let us know.
So there are the layers and then the different base maps.
Right. So these are layers that are essentially, these are the GIS layers that are coming off of Ecology's GIS homepage, which we all have access to in ArcView if we have that program. You can also change the basic base map that is used for the map within EIM. You have a few choices to choose from there, from a grayscale to a shaded relief map if you want to use that. These are sort of fixed. I suppose we could add more if there are, ones that are particularly useful for folks. If you want a USGS topo sheet. And then these are scale dependent, so the more you zoom in, the map draws to the most optimal particular map for that area.
Can you select wells based on the accuracy
And you
of
can.
their location?
You can. So, for example, you could say, I'm interested in wells that have a land surface accuracy of plus or minus a foot, plus or minus a tenth of a foot. You can do the same thing with water levels or other parameters. So say I want water levels, but I only want them accurate to plus or minus a tenth of a foot. You can do that here. But remember, every time you do one of those queries, if that field is blank, you're going to not get those results in your export.
And this is Kristen here at Central. I just wanted to say you have to keep in mind that that's often a submitter-designated accuracy. So you have to always keep in mind that they're sometimes just designating what they think their accuracy is. It may not always be true.
Kristen at Central, who was data coordinator for TCP data for a long time, is saying that sometimes the submitter doesn't submit the best accuracy. We work with them to try to establish the best data, but sometimes it's not always possible. So just keep that in mind.
One other feature I'll show you since we're in map here is you could actually, if you're interested in zooming to a particular like township range section, you can do that with the Find toolbar here. More than anything, at this point, I just encourage you to use the system. You can't hurt it in search. It might not work sometimes. If it doesn't, send us a burr so we can fix it. But I think you'll find it's a really powerful and useful tool for sort of getting at information in a way that we've never had before.
And if you have questions, feel free to ask your data coordinator for cleanup. It's Jenna Durkee or Eve, Carolyn Lee. You can always call me, or Kirk or Charles if you have questions.
And equally importantly, if you have metadata that's not in the system, if you know how deep the well is, you know where it's screened, take it on yourself to get those projects up to snuff so that you can search by them.
Yes, with legacy data, there can be a wide range of accuracies, and we state the accuracy in the metadata.
Okay.
So as we have moved the old data from independent databases that have existed out in the different programs, as we move that data and centralize it into the EIM system, we assign an appropriate accuracy value to the X and the Y and the Z coordinates. And we do that on the basis of what the records say in the original database, what the field records say, talking to the originators of the data. And then if there's a low confidence in the accuracy of the position of the well, we'll include that in the metadata for the well as we load it into the EIM system.
Somebody asked, so is this all internal, or is some or any of this information available to the public? And actually, everything that we're showing you today is available to the public with the two exceptions. Number one, the public doesn't have the ability to edit information. That's only reserved for people that are employed by the state's Department of Ecology. So there are actually two different versions of this web page right here, what we call the EIM Groundwater Data Center. There's an internal version, which is what we're looking at right now. And the difference is that it has this editing capability here. There's an external version that is available on the web to the public that allows them to search the EIM database for groundwater, just like Kirk showed you earlier in the morning. They can also submit data, so there's a consultant working for PLP on a cleanup site. They can upload data, but they don't have rights to edit that data once it's into the system. They have to work with the ecology project manager or the ecology hydrogeologist or the data coordinator to do any further editing that they need to do. So what you're seeing today, we're working on the internal version because all of you have access and you can sign up for rights to use the system, to use it to upload and edit information. We're going to walk through a thing that we call the report finder that a lot of people may not be aware of. It's a new tool. Chris is then going to walk you through a little bit of information about how the batch load process is done. We have two procedures for uploading data to the EIM system. If you have a lot of data, there's a template approach that you use, a template spreadsheet that allows you to upload information in big chunks all at one time. And then there's ways to upload just individual records. Say you're dealing with one well, or let's say that you just went and came back from the field after measuring one water level, there's a different way to interact with the system. So let me take you to this report finder tool. So before we leave this EIM map service, I wanted to show you this extra feature that's in there. It's a fairly new feature. It's only been up and running about, I don't know, 3 or 4 months now. So over the years, we have been compiling a library of groundwater technical reports across the state of Washington, and we've been mapping those reports in a GIS environment. And we built that into a database, and now you can have access to that database in a map environment, so you can search for technical reports that might explain the monitoring information that you're searching for and downloading from the EIM system. In a lot of cases, those monitoring results are documented in a technical report that's been prepared either by the Department of Ecology or a consultant or whatever. And these, we've been working now for a couple of years on this library. We've assembled reports from the water supply bulletins from back in the 70s and 80s are in there. Groundwater management area reports are in there, grant reports, the publications that are put out by the EA program, my program. We do not yet have the cleanup DSARS documents within this database, but that's been one discussion is to associate or build in the DSARS literature into the searching feature. So here's how it essentially works is on this toolbar at the top here, there's this thing called Report Finder. And what we've done is as we enter these technical reports into the database, we essentially flag them. What kind of categories of topic or theme is discussed in this report? And one report could have multiple themes that it's categorized by. But I can add a couple of different categories here. And you can see an example of, so these are the mapped extent or the approximate footprint of each one of these studies that meets that filtering criteria that I just set. So let me give you an example of how I might use it. I might be working in let's say up in the Dungeness Squim area, and I'm zooming in, and now I can see all of the reports. There's these orange polygons. Some are circles, some are rectangles, some are complex polygon shapes. But it shows you the approximate extent of those. And if let's say I modify my search, and I say I'm going to pick a point, and I want to know all of the reports that meet those criteria, these 3 topics, within a 1 mile radius of the point that I pick. And up comes a list of those documents. And we have quick links to those publications, so I can open up any one of these publications just using the quick hyperlink that's next to it. Can also, if there's additional information, so let me just show you an example. Here I've got an Aquifer Test report. That test report has been embedded into the report database, and we have a quick link to that report. I can also, if it's been associated, if the person that loaded the document into that database associated that particular document to some other piece of information, some other piece of digital information, and they made a digital connection, a link to that, then we go ahead and establish a link to it. For example, this Aquifer Test report publication that I could open up, that I opened up earlier, also has been linked to the well log for the well that document is about. So we're making all these connections between things. That's really what it boils down to. So you can see this list of all these documents that land geographically in the area of interest, and you can associate them with the monitoring well locations that are in EIM that may have monitoring data as well. So this is kind of a nice new tool. There are about somewhere between 700 and 800 technical documents about groundwater. We don't include policy documents or anything. It's all just the scientific or technical information about groundwater across the state of Washington.
Batch loading groundwater data. Most of you won't be doing this. Most of the batch loaded data we get comes from the outside, from consultants working on cleanup sites or grantees, et cetera. And our data coordinators handle this data when it comes in. They review it and then actually load it into the system once they okay it. I just wanted to show you, though, what this looks like in the event that you would ever come to batch load your own data. We have a number of different templates from which you batch load data. You can see for wells, your result data. Time series would be your transducer data, water levels. We would never deal with bioassay and groundwater. For each of these, there's a template and corresponding help. If you have any questions about what goes into the template, the help is always here. And I just want to show you an example of what one of these templates looks like. This happens to be the location template where you would input your wells, and see the fields are color-coded, and this goes with the help documents, letting you know what to put into each of these fields. Coming back to this data loader homepage, at the top there are different categories for different types of data. I'll pick result data here. You can see there's a place where you would come to submit your data, so you import it from this, and I'm not going to run through that right now, but just to show you that it's there. And once you import your data into the system, they come in as batches, and those would be here, and then you would go on to load them into the system. And really, that's about it. If you ever have the need to load data into the system, contact one of us, contact your program's data coordinator or one of us. There's a certain amount of training that's required before you can do this.
So as Chris said, our intent today is not to really show you how to do that. It does require some training. We're just trying to expose you to the different types of things that you can do. I wanted to open up this idea of adding a single well. Let's imagine that you're just working on one well, or you want to interact specifically with one well and edit or update the information that's in the EIM system about that one well. Let's first pretend that I'm going to add a brand new well. And anybody have a guess what the very first thing is that I do before I add this well into the system?
Find out if it's already there.
Exactly. Thank you, Joyce.
So find out if it's already there is the answer.
So the worst thing you can do in a database is to duplicate records by accident. You don't want to put the same thing into the system twice, and goes back to this concept that you have a unique ID that identifies this well. So let's imagine that you're working with this well, but you didn't know 10 years before that somebody else had been also monitoring that well and maybe loaded some data into that about that well. So you got to check and make sure that it's not there. And our recommendation is that you just use the map search tool that Kirk has already shown you, and zoom into the area where you know the well is and see if there's a well in that area. And if you're not quite sure, open up the details about the wells that are sort of in the vicinity of that area and check and see what the metadata says about those wells. You can look at the well depth and say, oh, this is a 197-foot well that's already in there. That's definitely not the one I'm going to be putting in. So first of all, you just kind of make a quick search using the map, and then you can start adding the well into the system. So the other example would be that maybe I have a tag ID for this well that I'm going to be loading in, and so I just see if that tag ID is already in the EIM system, and it says, no, I didn't find that tag ID. So I've gone a kind of a two-step process to ensure that it looks pretty good, the odds are pretty good that I'm not duplicating a well that's already in the system, so I'm going to add this new well. And this opens up an editor that allows me to add a brand new well into the system. And this should look very familiar. It's just the blank form that Kirk showed you already that laid out all of the well details, all of the metadata about a well. Who owns it? Where is it? How deep is it? What's it made of? All that kind of information that goes along with a well. So each one of these, this form is broken down into sort of categories. Give me the basic details about the well. Again, the well owner name is not exposed to the public. That's the only thing that the public does not see on the public internet site. Is you can put that information in there, and sometimes that's very handy if you're monitoring a well and you need to interact with the person that owns that well and ask permission to make those measurements or to collect those samples. This is a good record for internal use, but this is never exposed to the public. You can see, Joyce asked earlier about the facility site ID. This is where you can say, this well is connected to this facility, and here's the ID. And here's a quick link that would open up the facility site web page and allow you to run a search and figure out the ID for the facility site for this well, copy that ID, and put it right into this field right here. Just note that similar to the other forms that we've shown you today, each one of these fields has a heading on it, and you can click on that field heading and it describes what it's looking for. What is this field particularly trying to capture? It also gives you some examples of the types of information that you should be putting in there. And the fields that have the asterisk are the fields that are required in order to get a well into the EIM system to meet the modern metadata standards, the minimum standards of the information that we need to have in the system from now on. As we've moved legacy data into the system, a lot of that information didn't exist and doesn't exist. It's just no longer in the records. And so we move those in and leave those fields blank. But from now on, from this point forward, if you put a new well into the system, it has to meet a minimum standard. Here's Kirk earlier mentioned how you can use the alias to connect your well in the EIM system by perhaps a different name that is used to identify that well in another database, perhaps external to the Department of Ecology. So I might put a USGS NWIS 15-digit ID for this well in there. Now we can make that certainly facilitates making a connection. We ask for basic information about the well construction with a particular emphasis on wanting to know where in the vertical dimension is this well open to the aquifer. That's really, monitoring data is very difficult or impossible to really accurately interpret without knowing where was this well open in the subsurface. So we're asking for the folks to put in a little bit of information about the upper and lower positions of the open interval. In some cases, that may be the same thing. If it's just an open-ended casing, you might put in that it's 150 feet at the top and 150 feet at the bottom of the open interval because it's really just a point in the aquifer. And the power of entering this kind of information about depth, about the Z position in the aquifer system, is that then you can query on the basis of where these wells are open in aquifer, and you can do this for well after well after well across the entire state of Washington. So when Kirk showed you that he ran a search and he used depth as a criteria, he was depending on people to enter this information about, well, where is this well from a vertical dimension? A couple of other key fields I just wanted to highlight. Number one is this one is the Aquifer Test. I have a yes, no, and a lot of these fields just have a ready drop-down list that you can choose from in this editor. It's really easy to interact with the editor. This Aquifer Test field is just saying if you have a formal Aquifer Test that's been a document that's been written up. I'm not talking about a slug test or a bail-down test that you might find on a well driller's log. I'm talking about a hydrogeologist or an engineer going out and actually running an aquifer test. If you have the report for that, you can upload that report into the EIM system and associate it with this well, and then just say, yep, This one has an Aquifer Test report. Back in the search, now you can go query, show me all the wells in this area that I'm working on that have Aquifer Test reports that I can download and read. It's very, very powerful. This other field right here is this well specifically being used in some way from a regulatory standpoint as the up-gradient point for the facility? Not that it's necessarily natural background, but that you're using this particular well, and the person that enters this into the EIM system gets to make this decision. This is the well that I'm using to do my statistics or for regulatory purposes. This defines the up-gradient condition at the facility. And then all of the other wells that are associated to that study or that facility, they can all refer back to this one location. And, you know, if you start thinking kind of big picture, I could go into the search and I could say, show me only wells across the entire central region of Washington that have been flagged as up-gradient. And compiled, synthesized together, I might be able to get a better understanding of what a background or an ambient condition is for a particular water quality parameter that I'm interested in regulating against. There's also the coordinate information that you initially put in. I just want to say that it looks like a lot of information here. If you have the information already in your hands, it takes about 10 minutes to load a well. That's a one-time thing. You never have to do it again. Take the 10 minutes, establish these connections, make these links, you know, give us the facility site ID, tell us something about the X and the Y and the Z information, and you're done. 10 to 15 minutes at the most. So Chris said earlier that we always prefer survey quality information. Nobody denies that that's the best way to go. That gives us the most accurate X, Y, and Z position in 3D space that we can possibly hope for. So if you have that information, and in a lot of cases on cleanup program sites, they do survey their wells to the top of the casing in a highly accurate fashion. If you have that information, go ahead and load it in. It's just as simple as identifying the datum that you used, assigning an accuracy, what kind of method you use. You can say this is survey quality information. You can do the same thing for the elevation information. So we have X and Y, but we also have Z. Somehow you got to tell us where we are in the Z dimension. You can do that from the land surface, or you can do that from the top of the casing, or you can do it from anywhere you want, but just tell us where you did it from and how accurate it is and what datum you use to do that. However, if you don't have survey quality data, you know, there aren't all that many options. In the old days, we used the USGS topo maps, and you could kind of interpolate between the two 40-foot contour lines and make a guess. And you could still do that. But there are better tools out there now to do this. And let me show you this one tool here. So I don't have survey information. I'm out and I'm doing some monitoring of a private water supply well. And I come back in the field, I know pretty accurately where it is in the field. I'd recognize it on a map if I saw where it was from a position standpoint. But I don't have a lat and long for that value. I flip over to the map service, and we're going to keep our fingers crossed that the map service is actually active today. There it is. Very good. And I'm just going to zoom in. And I'll keep zooming in. And I'll keep zooming in. Where should I go? How about right here? Another check, I'm making sure that there's no well that already is present in the same spot. Let's say that our new well is right here. So what I do is I pick this pencil icon on the toolbar, and I click on the map. I'm not quite satisfied. It's actually over on this corner right here. Okay. And I can zoom all the way in if I want to and really pin it down. We have nice orthophotography with high resolution, so you can really pin down the location, the X and Y location of where a well is going to be. I'm done. All I do is click this auto-fill the coordinates in. I'm taken back, and you'll notice that all of the coordinate information has already been automatically filled out for me by that tool. And it's also automatically assigned a plus or minus 40-foot accuracy. If you think that you're even more accurate than what the default accuracy assignment is by the computer, then you can just change that yourself and move forward. So what about the Z? Again, I don't have a survey a value for the land surface elevation at this wellhead, but I do now know the X and the Y position of this well pretty accurately. Well, if I don't have the survey information, I can click this button right here, and the system will auto-calculate the land surface elevation at that X and Y location that I picked above. So here's what's happening. The EIM system is going out and it's taking those X and Y coordinates that I just filled out above, and it's hitting out to a USGS digital elevation model service. And it's looking at anywhere in the state, it looks for the most up-to-date and the most accurate DEM value at that point that's available from the USGS service. If you're lucky and you're working in places where there's LIDAR, you might have a very, very highly accurate land surface elevation. Most of the state, about 2/3 of the state, is just 10-meter DEM, so that's the vertical accuracy of the land surface value that you're going to report back, and that's exactly what's happened here. It said, here's my prediction off of a digital elevation model of what the land surface is at this point, and I've assigned it a 10-foot plus or minus elevation accuracy. And somebody earlier said, can I query on the basis of this now, later, if I want really, really highly accurate wells, or I'm willing to accept a certain amount of slop in the vertical accuracy of the wells that I work with? You can define that in your search terms. So you put in some information about the water level and where you're measuring the water levels from. Tell us just where on the well you're measuring from, and where is that with respect to 3D space. And you can do that with respect to the top of the casing, or you can do it with respect to land surface. Somehow you got to reference the point that you then take all your measurements from and tell us about that. You establish an ID for that point, and then from there on, all of your water level measurements just say, oh, I happen to use measuring point number 1 for these measurements, and you can have 150,000 measurements all referring back to that point, all referring back to that measuring point. And the system then can make all its normalizing calculations to bring everything into common 3D space. So the last thing I wanted to show you is about the linking a well log, linking an EIM well to the well log system. So you have to remember that the well logs in the Water Resource Program well log database there's not much of it is digitized. Some of the fields on those logs are digitized in their database, but not many of them, and there are a lot of errors in the digitization. So that's part of the reason why we ask folks to go ahead and put some of the construction information into a digital form so then it's queryable, because those well log images can't really search on the basis of depth or anything, open interval depth, that kind of thing. So we need to manually establish a link to the well log, and here's how you go about doing that. So I'm going to click on this button, and what you really need to link to the well log is the well log ID. Well, how do I get the well log ID? I go out to the Water Resource Program well log database, so I can just click on this hyperlink right here and it'll open up the database. And once I get into the database, I can use their map tool. And let's zoom into some area of interest. So I'll go into Chelan, how about? And I'll zoom in a little bit further. And I'll select the wells where I think the well log is for this well. I can open up the PDF of the well log. I can check and see, yeah, that's definitely the one that I want to link to. Once you're convinced that you've gone through the list using the Water Resource Program well log search tools, once you've identified the well log that you want to link the EIM well to, just grab that ID called the well log ID. I copy that. I come back in here. I paste it in. Now there it is, it's found it in the well log database system. There's the name, got some completion depth information, a little bit of information to confirm that this is really the well log that I want to link to. I can even open the well log and look at it one more time until I'm absolutely convinced that this is the right log. And say, yep, I want to select that one and I want to link to it. If I said okay, I would link this new EIM well to a well log. That's all you had to do. But it's not an automated process. You have to deliberately and actively go out and link the EIM well to a well log. But once you do it, it's done. You're over. You don't have to do it again. Okay, so that's about editing. I'm going to take you back in. So let's now imagine that I'm going to edit the information for a well that's already in the EIM system. Somebody, maybe I put this well in 5 years ago, and I've come back, in the meantime, in the intervening time, I actually went out and I surveyed the well. So I want to update the elevation information for the well from this plus or minus 10-foot DEM value to a really accurate, highly accurate survey value. So I click on that system, click on the same button in that Groundwater Data Center, and I type in the identifier for the well that I want to work with. I asked the system to search for that well. It found that well, and I'm going to say, yeah, this is the one that I want to interact with. This is the one I want to update and edit. And here it is. We're back to the same form that you've seen compiled on the search side, where we summarize all the metadata that's been entered for the well by whoever entered the well initially. But this also looks like the same editor form that I was just showing you for adding a new well. It's the same form, but now in editor mode. And you can see across the top that the different metadata categories for the well are on these independent tabs right here. So if I were updating the land surface elevation, I'd activate the editor. I'd come into the land surface, and I'd update the elevation and correct the appropriate metadata as I needed to. And then I'd say update. And now that well has been modified and updated. And you can do that for pretty much any piece of information that's stored about a well in the EIM system, you can update over time. You can also, if you have, let's say, that idea that John Parrish went out and he measured one new water level. Instead of going through the batch upload process where he has to go to this spreadsheet and then upload the spreadsheet to the system, all he has to do is go to the editor, pull up the well, and he can add that water level to the system. That one single water level he can just add. You also have the ability to delete a record if it was a bad measurement. You found out later after you put it in that it was not an acceptable measurement. You can take it out. Let me show you one thing in particular, and this is one of my favorite things about the things that we've been working on in the last few years. I think that it has amazing potential, the more that people recognize what this can do. So there's the EIM database system, and there's the Water Resource Program well log database. This page that I'm going to take you to, we call the well summary page. And imagine that it sits in between those two databases, and it connects them. It's the connector page that gets EIM talking to the well log database. But it does more than that. It has the capacity to do much, much more than just connect EIM to a well log. It has the ability to store a whole bunch of extra information and extra documents about this well location. So let me give you an example. So this information is coming out of the Water Resource Program well log database. It's the metadata that they stored in their database about this well. They also have things like the notice of intent. So you could open up the document for the notice of intent to install the well. If the well has been decommissioned, you can also have the decommissioning report loaded up here. And then here's the link to the well driller's log that's in the Water Resource Program well log database. But here's the really exciting part from my perspective is this final panel on the bottom here, additional documents. I'm the owner of this well. I can upload any document I want that's connected in some way to this well. So, for instance, in addition to the driller's log, I've uploaded the hydrogeologist log, which the hydrogeologist log isn't in the well log database because the well log database is about tracking driller's logs. But we all know that professional hydrogeologists are out there also logging wells and making their own logs. So I've just uploaded that and connected that log to this EIM well, and that now I have permanent access to that. And the sky's the limit. Here, I've taken some photos of some cores while this well was being installed, and I can upload those core photos to this. And I've got a whole series of photos of the cuttings that we saw as we were logging this well while we installed this well. The sky is the limit. You can add all the documents that are connected to this well in some way. You can add right here, and it's there permanently in the record in a digital fashion. Let's see, Kirk and Chris, have I forgotten anything? I think that's probably the...
I guess I just wanted to mention that all those metadata fields that Charles just showed you are the same ones that are in the spreadsheet. When consultants and whoever is batch uploading, it's all the same data. And I also wanted to mention, you can come in and edit things, but you can't go in and edit anyone's data that you want to just because you're in the agency. That's it's restricted, and you can give permissions for people to edit your data, but not just anyone can come in and mess up your data. The question is, the geographic search tool that we saw earlier, is that the same as this tool that Charles just showed you where you upload documents associated to a particular well?
And no, the answer is no, and one of the reasons why is these documents that I just showed you, the hydrogeologist log and the photos of the cores, et cetera, they're associated with a point. They're associated with one well. The report tool, the report finding tool that I showed you earlier, those reports are not necessarily associated with one well. They may have an area. They may discuss the hydrogeologic groundwater numerical modeling for Pierce County. So they are not necessarily associated with a particular well in the EIM system, and that's really the main distinction. Joyce asked whether or not linking to a well log is a requirement or an option, and the answer is it's an option, because not every well does have a well log. That's really what it boils down to is, you know, the well log data system we know is not complete, so not all wells have one. That said, I cannot emphasize enough how important it is if you can do it, and if a well log is available, please make that connection. And if you don't have the time to do it, you can work with your data coordinator. If you work with a regulated party, you can get them to provide the well log and then ask the data coordinator to make that connection. It doesn't take very long. You saw how long it took. All I needed was an ID for that well log and about 2 minutes to make the connection, and then you're done. And it really helps because then it opens up all the information that's not digitally available about those well logs on those well logs. Bail down test information, the driller's description of the geology, all that stuff. The only way we can really get to that and associate to that is if you make that link. So.
The question was, if a project manager, say in toxics cleanup, saw that there were well logs in the Water Resources System database that weren't linked to EIM, could they do that, or would they have to do the whole training to be able to do that? The answer is, right now, in order to make edits, yes, you do need to do the training, but in the cases of toxics cleanup, it has a very good data coordinator working with them. The best thing to do would be to ask your data coordinator to do this for you. In this case, Jenna Durkee. So the question was, can we link to other agencies' databases, in this case, Department of Health? and their water quality data and well data? And the answer is not right now. It's another thing where we've been making so many of these links in just the past 2 years that the sky is the limit. So I can foresee that in the future. You can track the system ID in the Department of Health database, and you can use that as put that in as an alias in EIM. So you could pull data from both systems and then assimilate them using that ID.